Good evening. Today we are going to solve assignment number 5. So this is first problem, and the bending moment diagram of a beam shown in the figure below. Which one of the option might be the correct option? So now you can see in BMD we have a vertical line, means at this end we should require couple, that is moment. So here we have moment 0 as end support roller 0, cantilever we have 0, and here we have couple. So we have option as D. Then we have second problem, which of the conjugate beam. In conjugate beam, cantilever part becomes your free or cantilever. Then internal hinge, it becomes roller support or simple support. Then simple support becomes internal hinge. And then cantilever, it becomes fixed support. Now first check left support, left we have cantilever. So we have left cantilever. So we have option B. So we have this as option B. Then we will have this. So now in this, we will have this beam as given 50 kilonewton meter. Now in this we have 50 kilonewton meter. This will be moment. And if we will take moment about A0, then we will have 50 minus RB into 8 equal to 0, and it gives us RB equal to 50 by 8. Then equal and opposite we have on other side, and therefore we have 6.25. Now we will draw bending moment diagram, and then we will divide it by E. So we have this as 6.25 into 4, and it will take downward, and this will be 25. And now as this is M by EI diagram, conjugate beam, you have to actually study and then you can solve this. And then we have this also. If we will go on right of couple, then we consider couple 50 and it comes 25 upon EI positive. We are interested to find VA because in conjugate beam with M by EI diagram, you will get shear force that is equal to slope and bending moment that is equal to deflection. Now we are interested to find the slope, so we have to find value of VA. So we will take moment about B of this conjugate beam, and then that will give me slope at A. So we will have moment about A0 minus VA into 8 plus 1 by 2 EI into 25 into 4 into 4 by 3 plus 4 minus 1 by 2 EI. So first for this, so area we are going to get same. That is 125, 1 upon 2 EI. So area of this we have 1 upon 2 EI into 25, 1/2 base. So this is actually 25 EI. So this is 1 by 2 into 25 upon EI. So you can take this EI below 25. And here also we can take this below 25. And then centroid of this we will have 4 by 3. So 1/3 plus 4. So we have this will be 4 by 3 plus 4. And for this we will have 2 into. So this is 2 by 3. So this actually we have 2 into 4 by 3. So this we will get it as 8 by 3. And this already we have considered 8 by 3 and calculated value. That is equal to 0. VA we will get 16.67 upon EI. Now EI we will get from here 16 into 10 raised to 11 Newton mm square, and that is equal to 1600 kilonewton meter square. Now if we will substitute this value 16.67 upon 1600, this will give us value in meter multiplied by 1000. And that we will get, this we have 16.67 upon 1600. This value we have actually in radians. And therefore we will get this value that is equal to, I will just rub this part so you will not be confused with this. So we will have to go for VA, So this we will get 16.67 upon 1600, and this value we are going to get it as 0.01 radian, because we know VA that is equal to slope at A in conjugate beam. So this VA value gives us theta A, and that is 0.01 radians, and we have this option that is C. We have next determine the maximum displacement in the beam as shown below. So now where we will have maximum deflection. So maximum deflection we will have at slope equal to 0. Deflection at slope equal to 0. Now in last we will have VA now plus 1/2 x into y, and that is equal to 0. So we are going for slope equal to 0, equal to shear force equal to 0. And shear force we have, now I will consider half part only. So we have this value 16.67 upon EI, and here we will have this will be in upward direction. Now upward downward I am not going in detail with this, you can take anything, and this is 25 upon EI. So now we have shear force 0, so somewhere here, so this is y, this is x. Now if we will go y by x, that is equal to 25 by 4, and from this we will get y is equal to 6.25 into x. So this diagram, I have taken this diagram, so you can see this portion. So this is VA, and this diagram we have considered. And then now we will go with VA, we have minus 16.67 plus half x, we have x, into y we have 6.25x, and that is equal to 0. So we will get value of x from here. So we can go to the 6.25 x square upon 2, and that is equal to 16.67. Yes, and from this we will get value of x that is equal to 2.31 meter. And at this we have maximum displacement. Now we will solve this. So we have this as 16.67. Now this is 2.31 meters. Now this value we will get it as y, which is 6.25 into 2.31, and this is upon EI. And if we will go for the displacement, so we have to take moment at this. So we know moment gives us displacement, because in conjugate beam, bending moment that is equal to delta. And from this we will get that is delta equal to minus 16.67 into 2.31 plus, now we will have half into base is 2.31 into height is y, 6.25 into 2.31 upon EI into centroid we have x by 3, and x we have 2.31 upon 3. And from this we will get this value that is equal to minus 25.67 upon EI. This is in meters. Now if we will put minus 25.67 upon value of EI, already we have calculated 1600 into meter into millimeter 1000, and we will get this value that is equal to minus 16 millimeters. So we have 16 millimeter, which is option D. Now we will go to the fifth problem. So determine the deflection at point B of the beam shown below. Use conjugate beam method. Now first we will find reaction at C. So that is RC. So we will take moment about B equal to 0, and that is a right part, because hinge we have moment 0 from both sides, and therefore we will get it as minus 20 into 4 into 2 plus RC into 2 equal to 0, and we will get therefore RC that is equal to 80 kilonewton. Now if we will take a moment about A0, we will consider a whole part. So let this we will have MA, then we have minus MA plus 20 into 6 into 3 minus RC we have 80 into 4 equal to 0, and we will get MA is equal to 40 kilonewton meter. Now if so 40 kilonewton meter, and RA if we will apply summation Fy0, we have total 20 into 6 120 and minus 80 which is RC, so we will get this as 40 kilonewton. Now if we will draw bending moment, so if I will consider this beam, we have here RC and total we have UDL. And if we will draw bending moment for this, or first now we will go for M by EI diagram. So now conjugate beam, what conjugate beam we will get? Now try to understand this. We have this is internal hinge. So here it becomes simple support. Now it is continuous support. So it becomes internal hinge. This is cantilever. So it becomes fixed support. And this is fixed support becomes cantilever. Now we have this as 40 kilonewton meter, and moment about B we have calculated it as 0. So how we will get then? So we have 40 over here, as we have UDL, so bending moment diagram parabola, as bending moment increases our slope should decrease. So we will get like this. We need not require to go for whole diagram. And now if we will take moment about this 0, so what we will get? So delta is equal to bending moment equal to 1/3 into this value we have 40 upon EI. So we have 1/3 into 40 upon EI into 2, and we have this will be 3/4 from here. CG 3/4 of 2 and into 3/4 of 2, and from this we will get this 3 gets cancelled, these 2 2s are 4, and we will get 40 upon EI, that will be displacement at B, and 40 upon EI option we have D. So now we will stop here. So remaining problems we will solve in the next video. So thank you.